Okay, so welcome back. So today we're going to introduce the idea of a limit, the intuitive idea of a limit. And then we're going to give you the definition, the intuitive definition of a limit. And then we're going to build from there. So let's start with these three graphs. So I sketched these three graphs. Again, I didn't mark everything, but just to give you an idea of what's going on here. So at x equals 2, you can see that for all three of these graphs, they are not defined at x equals 2. Okay? For obvious reasons, you see that x equals 2 in the denominator makes the denominator 0. So these are undefined. Now, if we just stop there and just say, hey, these are undefined at x equals 2, then we miss a lot of information about the behavior of the graph around x equals 2, because all three of these graphs behave differently at x equals 2. So just saying there's a discontinuity or that it's undefined at x equals 2 just doesn't do justice to the behavior or understanding what's going on with the behavior of the graph around 2. Okay? So let's look at how we look at the behavior around x equals 2, or what we call a neighborhood of x equals 2. Okay? So if we take some open interval around x equals 2, that's what we define as a neighborhood. Okay? But again, that's just a little bit of jargon. You don't need to know that. So let's take the first one here. So let's ask ourselves, what is going on with this graph as we approach x equals 2 on both sides, on the left and the right? So as we approach 2 from the right, and as we approach 2 from the left, what's going on with this thing? Well, as we can see, as we get closer and closer to 2, this graph is approaching what? It's approaching 4. Okay? Okay, and so that would be something that we would want to know, possibly, that this graph is approaching 4. Okay? Or we would say that the limit of this function as x approaches 2 is 4. And the way we would do that symbolically is we would write it this way. The limit as x approaches 2 of f of x is equal to 4. Okay? Or we could just put in, as we will do later on, just put in the rule, right? So we would just write in the limit as x approaches 2 of the function is 4. And that's the idea of a limit. That's the intuitive idea, the intuitive definition of a limit. As what is going on with the function as we approach a certain x value. Now, whether the function is defined at that value is irrelevant at this point. Okay? So as you can see, we can have a hole in the graph, right? And so what is going on around that point is really at the heart of what we mean by a limit. It's like, what is the behavior of the graph as we get closer and closer and closer to a particular x value. Okay? Not necessarily what happens at that x value, but as we get closer and closer to it. Okay? We'll talk more about that next time.